Miss Hurd's GCSE Geography revision on tropical storms. What are tropical storms? A tropical storm is a natural hazard. A tropical storm occurs when tropical warm air rises to create an area of intense low pressure, much lower than the depressions experienced in the UK. As the warm, moist air reaches high altitudes, powerful winds spiral around the calm central point, creating the eye of the storm, and the warm air cools and condenses into heavy rainfall and thunderstorms. Tropical storms are incredibly powerful and can cause devastation to small islands and coastal regions. What are tropical storms called? Tropical storms have different names depending on the location in the world. Their location is their only difference. They are known as hurricanes in the Atlantic and Eastern Pacific Oceans, typhoons in the west of the North Pacific Ocean, and cyclones in the Indian and South Pacific Ocean. Each tropical storm has its own unique international name. These names are predetermined by the World Meteorological Organization. They are alphabetical and alternate in gender. For example, the 2020 name list starts Arthur, male, Bertha, female, Cristobal, male, Dolly, female, and so on. Tropical storms are more recognisable and engaging for the public when given names rather than coordinates. Names repeat every 6 years, unless a large loss of life or cost in damage would make it insensitive to repeat them. Where do tropical storms form? Tropical storms form over warm oceans above 27 degrees C, which explains where they are found in the tropics. They form in the summer and autumn when sea temperatures are at their highest. Most tropical storms form 5 to 15 degrees north and south of the equator. This is because the equator, there is not enough spin from the rotation of the Earth. The effect of the Earth's rotation is called the Coriolis effect. A tropical storm is a spinning mass of clouds. In tropical regions, the intense heat makes the air unstable, causing it to rise rapidly. These unstable conditions are important in the formation of hurricanes. How do tropical storms form? Air is heated above the surface of warm tropical oceans. The warm air rises rapidly under the low pressure conditions. The rising air draws up more air and large volumes of moisture from the ocean, causing strong winds. The Coriolis effect causes the air to spin upwards around a calm central eye of the storm. As the air rises, it cools and condenses to form large, towering cumulonimbus clouds, which generate torrential rainfall. The heat given off when the air cools powers the tropical storm. Cold air sinks in the eye, therefore there is no cloud, so it is drier and much calmer. The tropical storm travels across the ocean in the prevailing wind. When the tropical storm meets land, it is no longer fueled by the source of moisture and heat from the ocean, so it loses power and weakens. What are the structures and features of a tropical storm? At the start of a tropical storm, the temperature and air pressure fall. Air rises and clouds begin to form. It becomes windy. As the tropical storm continues, the air pressure falls more rapidly, wind increases, cumulonimbus clouds form, and there is heavy rainfall. There is then a period of calm with no wind or rain at the eye of the storm. The sun appears, so it gets warmer. Air pressure is very low. Wind and heavy rainfall increase dramatically again, the temperature drops, and air pressure begins to rise. Hurricanes are measured using the Saffir-Simpson scale. The scale goes from 1 to 5, 1 being the weakest, 5 being the strongest. The scale is measured against wind speeds. So, for example, a Category 1 hurricane has lower wind speeds than a Category 5 hurricane. Category 5 hurricanes exceed 252 kilometers an hour. Will climate change affect tropical storms? There is strong scientific evidence that global temperatures have risen over the last few decades. These rises may be impacting on the world's natural systems. Over the last few decades, sea surface temperatures in the tropics have increased by 0.25 to half a degree Celsius. As patterns of sea surface temperatures change, they may affect the distribution of tropical storms. In the future, tropical storms may affect areas outside the current hazard zone, such as the South Atlantic and parts of the subtropics. Hurricanes may also become more powerful. Some computer models also indicate that the frequency of tropical storms may decrease in the future, but their intensity might increase. Intensity appears to be linked to increases in sea surface temperatures. This concludes Miss Heard's revision on tropical storms.